Good afternoon. Welcome back. Happy Friday. All right, first a quick word about the tests. The average was quite good, so well done. If you would like to talk to me about your current standing in the class, maybe you are between like one grade and the next one and you want to know what you can do to get up there. Maybe you are borderline between passing and failing and you want to know how to fix that. If you want to talk about withdrawing from the class, like I'm open to all kinds of conversations. So just see me today, Monday, anytime, and we can talk. But overall, the results of the test were quite good, quite good. So our look at the calendar. We just had our test. I've highlighted 5 things there. What word appears in all 5 of those? Functions. So you can see we are going to spend a lot more time talking about functions, different kinds of functions here, combining them today, a couple of days on inverse functions, something about quadratic functions, and then polynomial functions, functions. And then after that, we kind of change gears and things will look a little bit different for the next 5 classes. All right? So that's that. And because we just had a test, we have a new packet. So you guys are on page 1 of the new packet. How many pages are in this packet? Is it 91, 92? 92. All right, so there's a reason. There's a reason this one is thicker than the other ones. The other ones were like 60 somethings. This one is thicker because this is the last one for the semester. And you can see after the 3rd test, there's still like another week and a half. So that's why this one is thicker. All right, so it's the last handout I will give you this semester. And we'll go ahead and start on page 1. Can we go with Taylor L? Okay, Taylor M. Go ahead. Okay, can you guys try those 2 things, maybe without a calculator? We're looking for P of 30 and P of 40. Do we get 10 for P of 30? And how much is P of 40? 5. Any questions about plugging in? Okay, I'm hoping we're good at this by now, but I'd also like the interpret. So can you guys write down, you don't need to write down something for both, but can you write down one sentence for the thing that's up here in blue? The fact that P of 30 is 10 means something in terms of Rubik's Cubes. Write down a sentence. Okay, can we get somebody to share their sentence? Everybody here? Everybody hear what Hazen said? If you set the price at $30, then you can sell 10 Rubik's Cubes. Is that right? Or is that backwards? Is that right? Is that 30 the price, or is that 30 the number of Rubik's Cubes? Yeah, because it says here that, let's see, we set the price at that. We can sell X Rubik's Cubes. X is the price or the number of cubes? It's the number of cubes. So if you want to sell how many cubes? 30 cubes, you charge 10 bucks a piece. That's what that says, okay? So really, you just got to be careful about which one is which, and it means careful reading of the given, right? It tells you X is the number of Rubik's Cubes. And if you want to sell 40 Rubik's Cubes, then you're going to charge 5 bucks a piece. Does that make sense? If you make the price lower, you can sell more stuff. Okay, so I think that's all right. Okay, let's go to Andy for B. Okay, so suppose that we sell 30 cubes. and I want to know the revenue. Now the revenue depends on how much you charged for each of them, right? So if you're selling 30 cubes, how much did you charge? $10. That's the sentence you guys just wrote down. So if you want to sell 30 Rubik's Cubes, you're going to set the price at 10 bucks a piece. How would you find out the revenue? I feel like multiplying, right? 30 cubes, 10 bucks each. You just made $300 in revenue. That makes sense? Number of cubes times the price per each one. Go ahead and figure out the revenue for selling 40 cubes. What's the price if you're selling 40? It's $5. So in this case, we make $200. Why did it go down? I thought selling more was better. We lowered the price, yeah. Like where there's a trade-off here. Like you might be selling more cubes, but if you lower the price too much, then you're not getting enough money per cube to make up for the extra Rubik's Cubes you just sold. Okay, so let's jump down here to C, and we'll finally start to getting into some of the combining functions that you guys read about. We'll go to Tyler. Okay, lots of symbols, but we'll wade through these, and I'm hoping they'll make sense at the end. So we've got this new function here called R of X. And it's got that crazy definition. It says F times P of X. I'm just going to copy it here. So there's a lot of symbols until you understand how to read them. This F times P of X means something very simple. It means you take the F of X function, and you take the P of X function, and you multiply them together. That's what it means. You see that symbol in there? It says really you just separate the two functions, multiply them at the end. What was the F of X function for this example? It's X. I gave it to you right up above. So instead of F of X, I'm going to put X, and I'm going to highlight that that is the same as that. Times. The P of X function is up above. What is it? 25 minus 1/2 X. Different color. All of that is that. Do we see the two things multiplied together? Make sure we put parentheses so we really see two things being multiplied. The questions on the symbols? There's a lot of symbols until you see how to read it. Once you can read it, it's easy. So what we just did is defined that symbol right there. You see F times P of X. It just means you find your F of X function. Separately, you find your P of X function, multiply them together at the end. That's all that this symbol right here means. Questions on that? Okay, before we try to understand what this has to do with Rubik's Cubes, can I just say that we had two functions. You had an F and you had a P, and you just created a new function called F times P. And that's the point of today, is taking two functions and creating a new one, all right? One way to do that is to multiply them. Just like you could take two numbers and multiply them and create a new number, you can take two functions and multiply them and create a new function. Okay, so what is this formula really telling me in terms of Rubik's Cubes? Again, what did X represent? What was it? Yeah, that was wasn't that the number of cubes? And what was this, what was P of X? Was the price per cube? And if you multiply the number of cubes by the price per cube, what are you really finding? You're finding the revenue. Isn't that exactly what we did up in part B? You took 300 cubes times it by the price per cube, and you got 30 cubes times the price per cube. Got the revenue of 300, 40 cubes times the price per cube, x cubes times the price per cube. So this new function is called capital R of x. I'm trying to lead the witness here. What am I thinking of when I say R? Revenue. That's the revenue function. If you want, you could distribute. I'm quite happy leaving it as it is. Let's come down here to D, and we'll go to Katrina. Okay, so let's try this. C of 30. The cost of producing 30 Rubik's Cubes. They cost $4 each. What do we do to find the cost of producing? You guys buy it? 30 cubes. They cost $4 each. Multiply them together, we get $120. That's what it costs us to produce these things. Hazen, is that all right? If you want to make 40 Rubik's Cubes, what do you do to find the cost? 40 times 4. So it's always $4. It doesn't change anything. Every cube you make costs $4. So that's $160 that it costs you. Now we ask you guys to make this leap in number 2. Find a formula for C of x. Again, x is the number of cubes that you buy, that you make, that you sell. X is the number of Rubik's Cubes. Let's see some hands. How many of you feel like you have a formula for C of x? The cost of producing or manufacturing X Rubik's Cubes. All right, I see a few hands. All right, so let me say this. At every table, I see some hands that are not up. So if your hand is up, talk to the people whose hands are not up and convince them that you know the formula for C of x. Go ahead. X. Oopsies. C of x is 4x. We buy it. 4 times the number of cubes that you manufacture or produce. Let's try 3. Brian? Okay, new symbol. The new symbol here is this guy, R minus C. It's supposed to kind of remind you of the symbol that we dealt with up here, F times P. Remember, F times P just said take F of x and multiply it by P of x. This R minus C is going to mean take R of x and subtract C of x. So let's just write it out. I'll copy this part. And we get to the definition here. What does that symbol mean? It means you take R of x and you take C of x. And what do you do with them? You subtract them. That's all that the symbol means. This R minus C business just means you take your R of x, take your C of x, separate them, subtract them. Okay, but we have formulas now for all this stuff, so let's see if we can find them. What was our R of x formula? I think it was up above. So it's that x times 25 minus half x. Highlighted in a different color, so that is that. And then C of x, that's the 4x. We just found that up above. So we're going to subtract 4x. I'll just kind of circle it. That is that. I'm going to go ahead and crunch this together just to simplify it. So it's not going to look like this anymore, but at this moment, you can clearly see the two functions separated, and now they'll work together and kind of mingle. So let's distribute the x first. So we go, what do we have there? 25x minus a half, what? X squared, and then minus the 4x at the end. Yeah, so then we do have some like terms, right? So it's a minus a half x squared. And then how many x's do you really have? 21x. I guess I would say that's my simplified version of the formula for p of x. There's pros and cons for doing that. Pro is it's simplified. It's cleaner than the thing that was up above. I would argue that that is easier to look at than that. The con is that when it was this, you can tell them apart. You could clearly see what they were. Now they're all kind of jumbled together. I can't tell what it came from, but it's a trade. And now we're, Derek? That's the distributing. This x comes in and hits the 25, and it also hits the minus 1/2 x. So when we multiply the x times the 1/2 x, that's this guy right here. Are you talking about this x? So we have an x here. It comes in and hits that one. Oh, this one right here? That was a copy of this. All we did is copy that thing straight down here. Yeah, so it was already there. Yeah. Okay, and can we figure out, let's see, this R, what did it stand for? It's the revenue. C, costs. Can you guys give me a business type word that when you subtract revenue minus the costs, what are you really finding? You're finding a profit. So we called it P. Again, it's kind of leading the witness, but this right here is the formula for the profit for selling X number of Rubik's Cubes. Okay, so let's try number 4. We'll go to Ben. Okay, so let's try this. First thing I want to know is what is P of 30? 30 Rubik's Cubes, I want the profit. I've got my formula right up above, it's circled in red. So we're doing negative 1/2 times what? 30 squared. Maybe I'll put over here just to remind us that this is your P of X formula. That's the one we're using. And then continuing in that blue formula there, plus 21 times what? 30. Okay, and so we're going to get some number here, and that number is going to be the profit from selling 30 Rubik's Cubes. Anybody have a number for us? One vote for 180? Several votes for 180. Okay, fair enough. You sell 30 Rubik's Cubes, your profit is 180. Let me tell you, we probably could have gotten that answer even easier. Come up above. We just have to find the right number. What was the revenue for selling those 30 cubes? It was the 300. That was this. What was the cost for 30 Rubik's Cubes? The cost to us was a 120. So looking at the 300 that we made and the 120 that cost us, how much is our profit? It's 180. You subtract them, right? Okay, so if you just want that, then you do it up above and it's fine. The nice thing about having the formula, I mean, that's the 180. That's the right answer. The nice thing about having the formula is that if you wanted to find the profit for a lot of different levels, like 30 Rubik's Cubes or 40 or 50 or 57, we have a nice table feature on our calculator, don't we? Couldn't we plug that guy in? I don't need you to do this now. I'm just giving you kind of why we would care about doing it this way. 1/2 x squared plus 21x. And if I go into my table and I say, okay, how much money do I make really if I sell 30? Okay, that's $180. What if I sell 40 of them? Oh, that's not as good. Maybe we should go the other way. How about 25 of them? 25 of them is that? Oh, that's better. I feel like it's a lot quicker to find the profit for lots of different numbers this way than to do it the piece by piece way up above. So I'm just trying to give you a sense of like why we might care about doing all this when you could just separately calculate the revenue every time, calculate the cost every time, and subtract. It just feels like if you're doing it repeatedly, this is easier. It's less work. That make sense? Okay. All right. How about we jump down to 2? Composing. Where are we now? We'll go to search. Good. Let's go to Joe for A. Yeah. So how do you read that? Okay. So I hear some people saying G circle F. I don't really like that. I also hear some people saying Goff. I really don't like that. But I do like the word of. G of F of 3, because that's exactly what this thing means. It means you take your G function as the outside, you take your F function as the inside, and then the one number goes smack dab in the middle, the innermost place you can find. That 3 is right in there. So reading it as G of F of 3, I think, is a good way to read it. If you were faced with G of F of 3, which function would you do first? Would you do the G first, or would you do the F first? The F first. And so one thing to take away from this idea of merging functions together in this new way is you work from the inside to the outside, always inside to the outside. So I'm going to copy the G because the G is just sitting there waiting its turn. And what I need to find out is what F of 3 is. Well, I can do that. I've got my F formula right here. How much is F of 3? F of x is x squared. So F of 3 is 3 squared, or 9. So where do we put the 9? It's in here. G of 9 is what we're after. Does everybody see the highlighted things are the same? It's really just a replace. Instead of F of 3, write down what it really is. It's 9. Which one? The circle? Well, we'll talk about composition for a few different times this semester. And then G of 9, okay, this is a little bit more work, but you have your G function up above. You plug in 9 for all the x's. We'll write it out. On the top, it goes 9 minus 5. On the bottom, 9 plus 1. 4 over 10, 2/5. So G of F of 3, 2/5. Derek, where did we lose you on that one? Okay, so first thing to do is translate this G circle F. Doesn't have any meaning besides what we've written down here. You put the G, then you put the F, then you put the number. G of F of 3, and we always work inside out. This F of 3 is the inside thing. We have to find it. F is given by that rule. So F of 3 is 3 squared. We put it over here on the side. F of 3 is 9. And so that 9 ends up replacing the F of 3. And then we have to start all over. G of the new thing, G of 9. And we plugged in 9 for this function right here. 9 on the top and on the bottom for the x's. Let's see if we can't do something. Just want to show you because you're going to have a real big group activity you're going to do in just a minute. And part of it is going to involve doing this thing on the calculator. You don't need to do this at the moment, but you will have practice on the activity. But I'm going to type in x squared as my first function. So we go x squared, and then the second function is this x minus 5 divided by x plus 1. Have I typed that correctly? Do we put parentheses? Am I really telling the calculator what's written on the paper? I'm really not. I'm really not. Yeah, the calculator thinks I want to do 5 divided by x. It's following the order of operations. Yeah. 5 divided by x. Yeah, that's really not what I want. So how many sets of parentheses do I need? I actually need 2. One there, and then we'll close it. That's our way of saying the top is really separate from the bottom. But then you also have to say the bottom is separate from the top. Okay, so I think that is typed in correctly now. And then here's what I'm going to do. Let's see, which function was the outer one? F or G? G was the outer one. G is y2. bars to the right, function y2. That's the g function, right? Of, just like we wrote here in purple, g of f of 3. That's what I want. I want g of f. y2 of what? y1. That's the f. Bars to the right, function number 1. Of. It's kind of a mess, but if I ask the calculator to plug in, what number did we plug in ultimately? We plugged in 3, didn't we? Let me delete some of this mess. If I plug in 3, what's the right answer? The final answer was 2/5. Okay, does that 9 look familiar? That's the f of 3, that's the first part. Does that negative 0.5 look familiar? No. What is that? That's g of 3. Did we care about g of 3 for this problem? No. So of course we haven't seen that number, but if I scroll to the right, then we will find y3, which is this composition. And how much is it? It's 0.4, which is 2/5, 4/10, right? So it can handle composition. You do have to pay the price a little bit, and you have to type in some messy stuff up there. y2 of y1 of x. We'll do that on the activity. Last thing we do together, part B. Let's go to Sam. We're on the bottom of page 1. That's read correctly. G of f of x. In fact, I'd really like to write that as my first step here. So I'm copying the original. And then Sam says G of f of x, just like that. Write it a few times and it will get easier every time. Which one goes first, outer or inner? Inner is first, which means G is just sitting here waiting its turn. So I will copy it. For this example, what's the rule for f of x? It's circled in purple there. It's x squared. That is what f of x is. We are going to put x squared, and we're going to highlight that this is the same as that because of that. So f of x becomes x squared. All right, this last step is the hardest part of composition of functions. We're looking for g of x squared. In English, g is a complicated function. It takes whatever is in the parentheses, it puts it on the top and subtracts 5, and it takes that same thing in the parentheses and puts it on the bottom and adds 1. In English, that's what g does. Whatever you give g, it puts it on the top and subtracts 5, puts it on the bottom and adds 1. What are we giving g down here? What are we feeding the g function? X squared. We're not feeding it x. Normally you feed the function an x. But here we're feeding it something more complicated. We're feeding it an x squared. But g doesn't care. It takes whatever's in the parentheses, sticks it on the top with a minus 5. On the top with a minus 5. On the bottom, what does it put? We need more highlighted stuff here. I don't know. This x squared goes where there used to be an x in the original function. Again, g takes whatever you give it in the parentheses, it sticks it on the top with a minus 5, sticks it on the bottom with a plus 1. We're really used to x, so now I'm asking you to make a leap. Make a leap where you can change that x to anything you want. In this case, I need it to be an x squared. So right up here, instead of x, what should it be? X squared. Down here, instead of that x, what should it be? X squared. Every x becomes x squared. You write your answer, we're done. I think that's the hardest part about composition of functions. Questions on that one? Okay. So I'm going to stop talking because there's massive group activity here. You guys are my guinea pigs with this activity. I've done 107 a few times at GCC, but this is the first time I've done this thing. I found it over the January break, and I think it's good. I will let you guys tell me whether or not it's actually good. So we have 40 minutes. I think you guys can complete this in less than 40 minutes. Take your time, but work at a good rate. And at the end of that activity, you will eventually find answers, followed by a second activity. Maybe the goal is to finish both. Let's see how far it goes.